So,
Okay, nice. So, hope you guys have covered the lectures video and you got the concepts of permutation, combination, and addition rule of counting for multiplication rule of counting. Is my screen visible to us, to all of you?
Yes, Prashant.
Okay. Okay, so we will start uh, the last session. We have covered the up to week 4 videos. Okay, so now we will start with the week 5 video lecture. So, and the notes, the last session of up to week 4 you have asked, and I somehow I was not able to share with you. So now I will share the notes of the previous session as well. Okay, so tell me, suppose any action A is any action, whatever you have, is occurring in N1 different way, and any action B is occurring in N2 different way, right? Then what will be the total number of occurrences of A or B? Anybody?
N1 intersection
N1 plus N2.
A intersection.
N1 plus N2, right? That means suppose you have 3 shirts, right? Okay, and 4 pants. Okay, then I says you can select a shirt or a pant. Then in how many ways you can select?
It's N1
7
into
ways?
N2.
No, I'm asking or not and. I'm asking you can choose a shirt or a pant, right? Then I can choose any of the 3 shirt or any one of the 4 shirt. That means I will have the 7 ways in total.
Okay.
Are you getting? Okay. Suppose any action A is occurring in one different way, okay, and B is occurring in 2 different ways, then number of occurrences for A and B, how many it will be?
N1 into N2 is.
N1 into N2. Suppose question is, I have to choose, I can choose a shirt and a pant, then I can choose in 12 ways, right? Because suppose you have 3 shirts, S1, S2, S3 and 4 pants, right? That means P1, P2, P3, P4. Then I can choose S1, P1, right? A shirt and a pant, not or. A shirt and a pant. S1, P2, S1, P3, S1, P4, right? Or I can do S2, P1, S2, P2,
Sir, I
S2,
can hear you.
P3.
Hello.
Hello, am I audible?
Yes, Prashant.
Yeah. So similarly, I can do
Sir,
for
I can
S3,
hear you. I
S3P1.
can't. Hello.
Hello. And Navneet, please check your network connection. I think I'm audible for rest of the people, right?
Yes, sir.
Okay.
Not
So
clearly, sir.
now clearly, now is it okay?
For me, it's clear, Prashant.
Okay. Okay. Then similarly, I can choose shirt 3 and pant 3, shirt 3 and pant 4. Similarly, okay. So how many ways I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, which is this one. So when your action A is occurring in one different way, or and action B occurring in two different ways, and question is what will be the total number of occurrences for A and B? Then it will be N1 into N2. That means 3 into 4. That is 12 ways. Is that clear? Hello.
Yes, sir.
Yes, sir.
Okay. Okay. Suppose I'm saying a student, suppose Suman is there and she wants to set password for her laptop, and she wants to set a 4-digit password, right? For which like here C has condition like C can choose an alphabet, okay, of both. I mean, as well as small and uppercase and lowercase also. Okay, that means she can use any of the alphabets, lowercase as well as uppercase alphabets. Okay, then okay, and which is I'm saying repetition of the alphabets is not allowed. Okay, repetition is not allowed. Then in how many ways she can choose the password for her laptop?
Even for digits, the repetition is not allowed.
See, she wants to set a 4-digit password. That means okay.
Yeah,
And
yeah.
she has an option. She can choose an alphabet from a lowercase as well as uppercase.
Correct. No,
And repetition of the alphabets is not allowed.
repetition of digits is allowed.
No, I'm not asking about digit. I'm saying she has only 4. She has to choose from the alphabets.
Okay, okay,
That's
okay.
not digit.
It's
only
52
characters.
Okay,
Is
okay,
it
okay.
24, sir? Is it 24?
Got it, got it.
52 into 51 into 50 into 49.
Yes, Shilpa is the right. Because
24.
see,
4 into 3 into 2 into 1. Yeah.
no. Why 4?
No, no.
See, she
2
has
into
to set
51.
2 into
4
51
digit.
into
I mean, see, normally you have to 4. You can say 4 characters. Let's say you have to set a password of 4 characters, right? That means you have to choose. Okay, and she can use any lowercase or uppercase. For lowercase, you have 26 alphabets, right? And for uppercase, I have also 26 alphabets. That means in total, I have 52 alphabets. So Suman can use any of the 52 alphabets for the for setting the password, right? Then for the first place, she can choose. She can use any of the 52 alphabets, right?
Yes, sir. Yes.
yes.
And for the second place,
51.
see,
Any of the
I'm saying
51.
I'm saying
51.
repetition is not allowed.
Yeah.
That means one alphabet is already used here. That means 51
The
will be
51 alphabet.
remaining. Okay. For the third place, it will be 50. And for the fourth place, it will be 40.
49.
Okay. Is that clear? So see, here multiplication rule of counting is used. That means you can make event A as selecting alphabet for the first place, for the second place, for the third place, and for the fourth place, and all, and so on, right? So is that clear? I mean, is this clear now?
Yes, sir.
Okay. Okay, suppose I'm saying she can use any an alphabets, okay? Okay, of lowercase as well as uppercase, okay? Or she can use numbers also from 0 to 9 for making a password, and repetition is not allowed. Okay, suppose repetition is not allowed there, then tell me in how many ways she can make the password, and she has to make the password of 4 characters or 4 alphabets. So in how many ways she can do?
Is it 61 into 61 into 60 into
62.
62 multiplied
into
by 61
62 into 61 into 60 into
If
into
you
59.
focus, no,
15.
if
first
you
character
focus,
cannot be 0, right? So it's 61 into
no, it's not about 0. It's not about 0. Say password. If you put a password, then
Password can be
see, I'm asking what is the question. I'm said she can choose an alphabet. She can choose numbers. Are you getting my point? She can make the password by using alphabet, or she can make the password by using number. Then in how many ways she can do? Are you getting my point?
36 into 35.
36 into 35 into 34 into
Why
30.
36?
Oh, 62 into 61 into 60 into 59.
No. I'm saying she has to make password either using. If password is
62
not
into
alpha
61
numeric,
into 50 into 49 plus 10 into 9 into 8 into 7.
yes, Dhruv, you are right. I'm saying she has to make the password by using alphabets or numbers, right? Then C can make the password by using alphabets in how many ways? 52 into 51 into 50 into 49, right? Or C can make the password by using number in how many ways? At the first place, I can use any of the 10 and for the second, any of the 9 and any of the 8 and any of the 7. So you have to add these two quantity. So total number of ways will be this things plus this things. Is it clear now?
Yes, sir.
Okay. Suppose question is like yeah, suppose there is some manipulation. Manipulation is, you can say, suppose she wants to use alphanumeric password and then she cannot use the small alphabets. That means she has to use only uppercase alphabets. Okay, this is the another condition. Let's assume. Then suppose I'm saying that she can use first digit as only the first digit, okay, as alphabet, okay, and she can use numbers also 0 to 9, right? See, listen to me carefully. I'm saying she can use uppercase alphabets and first digit of the password, okay, should be alphabet, and she can use the, she can do. Are you getting my point?
Can you repeat the
I mean,
question?
I'm saying she has to make the password of 4 digit, right? Now I'm saying she can use the only uppercase alphabets, and at the first place, at the first digit, she has to use alphabet. Then in how many ways she can do?
Is repetition possible?
No, repetition is not there. Repetition is not there.
So if I've understood correctly, like out of 4, the first one has to be an alphabet and the other 3 can be alphanumeric.
Only numeric.
So
Because at
first
the
case, it can be 52, 51, 50, and 49 as usual, like
no
previous
Shilpa,
one.
no Shilpa.
Second,
No. I said she can use only the uppercase
26
alphabets.
P1 into 10 P3.
Yes, it will be for the first place.
26
Yes.
Into
Please go ahead.
10.
Yes, into 9
Into
into
10.
9 into 8.
Into 9 into 8.
yes, because what I said, at the first place she can use only the uppercase alphabet. That means she can use any of the 26 alphabets for the first place, and for the remaining 3 places she can use any of the, I mean, she has to use the numbers. So for the second place she can use any of the 10 numbers 0 to 9, and since repetition is not allowed, that means at the third place 9 will be there, and for the fourth place 8 will be remaining. I mean, you got the concept? Hello?
yes, sir, yes, sir. we got
Yeah,
it.
we got it.
Okay, just tell me, you are familiar with the factorial things, right? What is the meaning of n factorial? This is nothing but the n into n minus 1 into n minus 2 into up to 3 into 2 into 1. That is the meaning of factorial, right? Also, I can write n into n minus 1 factorial. This whole things, right?
Yes,
Okay.
yes.
And
Yes,
there
sir.
is some, you are familiar. What is the meaning of 0 factorial? 0 factorial, value of the 0 factorial is 1.
1.
Okay. So these are something you have to. And 1 factorial is also 1, right? Now, come to the,
Actually, is it Yan? Yan.
sorry?
I'm sorry. Is it Yan?
No, it's 1, 1, 1. 1 factorial is equal to
I
1.
understand it. Yeah.
No? Yes. Okay, just tell me, you know what is the permutation?
Yes.
Anybody? Yeah, what is the meaning of permutation?
Arrangements.
Arrangement
Ordered
is what?
arrangement of all objects.
Yes,
Ordered
ordered arrangement. That is the very important thing. Ordered arrangement of all or some of the objects, right? See, order, see, there is a very basic difference between permutation and combination. What is that? In permutation, order is matter, and in combination, order doesn't not matter. Okay, so in permutation, order, we have to do the ordered arrangement, right? Now, so if I am doing the without replacement permutation, okay, without replacement permutation, which we have did in the password example. So for, okay, for n distinct objects, so suppose I am interested for doing the possible permutations for of r objects out of n distinct objects, then in how many ways I can do? Suppose you have r places, right, and you have total n things, then I have to
N
do
factorial
NCR.
upon N minus R factorial.
yes. So
NCR.
just tell me, suppose you have r places. So for the first place, in how many ways I can do? I can put any of the n objects, and for the second, I can put any of the n minus 1. For the third, I can put any of the n minus 2, and so on. For the rth place, I can put any of the. Is this clear?
Yeah.
Okay. Now this formula will become, so similarly I can do n into n minus 1 into n minus 2 and so on into n minus r plus 1. So now can I do, if I want, so okay, suppose one second, can I do n into n minus 1 into n minus 2 so on n minus r plus 1. Okay, so I can multiply it by n minus r minus 1 up to 3 to 1. Okay, 3 into 2 into 1, divide by, see, this quantity I have multiplied, so I have to divide by this quantity also in denominator and numerator, right? Okay, so what is the numerator? Can I write numerator as n factorial?
What I say?
Okay, and denominator I can write n minus r factorial.
Yes.
Are you getting? Because n factorial is what? N into n minus 1, n minus 2 up to n 3 into 2 into 1, right? So similarly, n minus r minus 1 up to 3 into 2 into 1. So numerator things I can write as n factorial, and denominator thing I can write as n minus r factorial. So this is nothing but the NPR, which is called the possible permutation of r objects from a collection of n distinct objects. So which is, I mean, base root of the things is this. In for the first place, I can use any of the n objects. For the second, I can use any of the n minus 1. For the third, I can use any of the n minus 2. And for the rth place, I can use any of the n minus r minus 1. So by these things, our formula is came. Okay, meaning of the NPR. Till this point, it's clear for everyone?
Yes.
Okay, fundamental is clear. Okay, now you know what is the meaning of what is the value of NPO? Sorry, NP0. If you put, you will get n factorial divided by n factorial equal to 1, right? That means in statement we can say there is only one ordered arrangement of 0 objects, right? So similarly, what will be the value of NP1? Again, I will get n factorial divided by n minus 1 factorial. So numerator things I can write n into n minus 1 factorial divided by n minus 1 factorial, right? That means there are n ways for choosing of one object out of n objects, right? So similarly, you can find the value of npn, which is nothing but the n factorial, right? So see, in here we have did the permutation without replacement for r places, right? Suppose we have to do the permutation with replacement, I mean repetition is allowed, then what will be the formula? Anybody?
N to the power r.
N to the power r.
Yes, because there are r places and there are n objects. So for the first place, I can use any of the n. Since repetition is allowed, then again for the second place, I can use again any of the n. For the third, again n. Similarly, up to n. So this is nothing but up till the r times. Then it will be n raised for r. While in the without replacement, what is what? Without replacement, what? It was n into n minus 1 into n minus 2 into and so on n minus r minus 1, which at the last it became NPR. Now is it clear what is the basic difference between the with replacement and without replacement thing?
Yes.
Okay.
Yes.
Now,
Yes, sir.
okay. So let me create a new page. Yeah, one second. So tell me, there are you have suppose a test paper and there are 10 multiple choice questions. Okay. And okay. And suppose it contains you can say first suppose there are I'm splitting I mean I'm splitting the suppose for the first question first 5 questions there are 4 options. Okay, for each, and for the last 5 questions there are 5 choices, I mean 5 options. Are you getting, I mean, are you able to understand? There are test paper, there is a test paper of 10 MCQ, out of which first 5 questions has 4 options and remaining 5 question has 5 options, right? I mean,
Yeah.
Yes,
are you
sir.
getting? Okay.
Yeah, I understand it.
So tell me in how many ways answers are possible? I mean,
4 raised to
possible.
5 into 5 raised to 5. 5 raised to 4 into 5 raised to 5. Sorry, 4 raised to 5 into 5 raised to 5.
Yes, because see, for this for first question, any of the 4 can, I mean, there is 4 ways to select option, right? Similarly for the second question, again 4 option, again 4 option, again 4 option, again 4 option. So what is this? 4 into 4 into 4 into 4, that means 4 times 5. Okay, suppose this is your event A. Okay, let's make as A, and you have to consider B also. So for B, I can do similarly 5 raised to power 5. Now here I have to find the possible occurrences for A and B, because we have to consider 10 questions at all, right? So for A and B, how many ways we can do? N1 into N2. Okay, so N1 is what? Here we have 4 raised to power 5, and N2 is what? 5 raised to 4. So these are the total number of. Is this clear? Is it clear for everyone?
Yes.
Yes, sir.
Yes, sir.
Okay, so okay, so suppose tell me, you have a question set of a question paper. There are suppose 6 questions, right? And each of the questions of true or false type, right? Each question has of true or false, and there are suppose there is an option. I mean, so tell me in how many ways you can attempt the question paper?
2 raised
2
to
raised to
6.
6.
I'm saying attempt the question paper.
3 raised to 6.
Yes.
We can leave
Why 3?
some questions. We can
Sorry?
leave the questions.
Yes, it's right. Because I'm saying, suppose you went, you are going to give an exam and you have options, right? You are going to attempt a question paper. Then you have options. Either you can select true or false or did not attempt. I mean, did not answer to that question. Okay. So for each question, you have 3 ways, right? True, false, and did not answer. Okay. Then it will be 3, 6, 3 raised to power 6. Right? Okay.
Yes.
Suppose,
Yes.
yeah. Okay. Suppose I'm saying you have 5 pen. Okay. And you have 5, okay, let's say 2 different, 2 blank boxes. Okay. Pen box is 2 you have, and suppose you have 5 pens So in how many ways you can arrange your pen in these two pen boxes?
20. No.
Yeah, please you can think.
Two raised to five again. Is it?
5 ways.
No.
0 in one, 5 in the other one, 4 in the first one in the second one.
5 in the first one, any of the 5 in the first one, any of the 4 in the second one.
That means, see, I can, let's assume I can take 0 pen in the first one, okay, and 5 pens in the second pen box, right? That means in how many ways I can arrange 0 pen in the first 0 factorial, and for the 5 pen I can do in 5 factorial ways. Are you getting?
Yes, yes.
Okay, because you have 5 pen and you have pen box, then let's take something box is like kind of this something, this box is, and there are 5 places. Okay, let's assume box is kind of this kind of, okay, something that means you can put as kind of, okay, suppose box is something, then for the first box I can put 0 pen, which I can do in 0 factorial ways, and for the in the second box I can put all the 5 pens, which can I can do in 5 factorial ways, because I can put in here any of the 5 and 4 and 3 and 2 and 1, which is nothing but the 5 factorial. Is this clear? Is it okay for everyone?
Yes,
Yeah?
yes.
Okay. Similarly, case will be there. Second case will be there. 1 pen in the first one, right? And 4 pens in the second box. Tell me, in first pen, in how many ways you can put?
1 factorial.
No, Ranjani.
1 pen is 1 factorial.
No.
5.
5.
5
Because
factorial.
you can take not 5 factorial, only 5, because you can take any of the 5. You have 5 pen, P1, P2, P3, P4, and P5. I'm saying I am taking 1 pen in this first box. Then I can choose any of the 5 pen, right?
Yeah.
Right?
Yeah.
Now for the remaining 4 pens, I can do 4 and 3 and 2 and 1. That is 4 factorial.
Okay.
Since we have to consider both cases, so it will be 5 into 4 factorial.
Okay.
Which
Correct.
is nothing but again 5 factorial, which is 120.
Okay, so you get 5 as 5C1 into 1 factorial, right?
Yes. I mean, you choose 5 and 1 factorial. Yeah, you are right.
Okay.
Since we are still in the permutation concepts, that's why I'm taking just a counting via counting. That's okay. Similarly, I can took 2 pens in the first and 3 pens for the second, right? In how many ways I can do 2 factorial? Is it okay, or is it correct or wrong?
It's 5p2, na?
Yes, it's a 5p2. It will be because I can choose any of the 5 and 4, right? So similarly for the 3 pens, in how many ways we can arrange?
5P3.
3 into 2 into 1, 3 factorial, because you have remaining 3.
Okay, so it's 3P3.
Okay, 3p3. Okay,
Got it.
so I can do 5 into again 4 into 3 into 2 into 1. That means again 5 factorial, right? All of you getting my point?
Yes.
Okay. Yes. Similarly, I can do 3 pens reverse case for the first, and now you guys will tell me a number of ways for the second box. Then in how many ways I can do for the 3 pen?
5p3.
5p3, that means 5 into 4 into 3. And for the 2 pen,
2p2.
2p2. That means 2 into 1, right?
Yes,
Again,
yes.
it will be 120.
Yeah.
Now, what are the cases remaining case? That means 4 pen in the first and 1 pen in the second, right? Tell me the number of ways.
5p4.
5p4, that means 5 into 4 into 3 into 2, that's right, and that will be 1. Again, it will be 120, right? Similarly, 5 pens in the first and 0 pen in the second box. It will be 5 factorial, it will be 1, that means again 20. So at the final, you will get how many ways? 3, 4, 5, and 6. That means 6 times
5
120,
factorial.
right?
Yeah.
That means
6
720.
Okay, great. Got it.
So you got the concept?
Yes, yes.
Yeah. Okay, so I'm going to stop sharing. Now from now onwards, Ishan sir will continue your session. Okay. So Ishan sir, I have completed the counting principles and concept of permutations. So now you can continue with the concepts of permutations and one kind and second kind and all of things. Okay.
Yeah, sure, Prashant.
Yeah. Okay.
Thank
Yeah.
you.
Thank you. Yeah.
Thank you
So
so
is there
much.
any option that we can access the recorded version of it if we had logged in late or something?
We will check with the team and let you know. Okay? You will get a mail accordingly. Yeah.
Okay, but that's what, since I missed out the last time classes, so if there is any option that we can check it out, the recorded version, if we can get it.
Yeah, sure. You can also write to support team or regarding it. I will also contact them and
Sure, sir.
ask if
Yeah.
it is possible
Thank
to
you,
share
sir.
the recordings.
Thank you, sir. Thank you.
Okay, moving forward. So now you all are clear with the concept of permutation.
Yes.
Any doubt in that? Okay, so till now you have done permutation of distinct objects, right? There are 5 pens and you have arranged, you can arrange them in 5 factorial ways. Or if you have to arrange them in 2 different blocks, like last question you just did, right? You are able to handle such type of questions now, right?
Yes.
Okay, so moving further, suppose all my objects are not distinct. Okay, firstly, suppose, let's say I have, let's consider a word. Okay, let's say I have these 5 alphabets, A, B, C, D. Okay, let's consider 4 for now. In how many ways can I arrange these 4 words? How many possible permutations?
4 factorial ways.
Right. Okay. Now suppose if I have 2 words as same, I have these 4. Then what will happen?
4 factorial by 2 factorial.
4 factorial by 2 factorial, repeated ones.
Yeah. Do you know the reason of why we are dividing by 2 factorial?
The repeated letters.
Non-distinct letters. The repeated letters can be arranged among themselves by 2 factorial ways. So to divide it. So,
yeah.
The words can be the same in the combination.
Yeah. Suppose my this A is A1 and this A is A2. Okay. And suppose I make a word A1B, A2D. Okay. And second one I make is A2B, A1D. These two are same, right? It doesn't matter which A I put first, which A I put second. At the end, I will get the same word, right? A, B, A, D. So that's why if you notice here, every 2 words make 1 word only, right? So in general, if I am able to make 4 factorial, unique ones would be only half of them. Rest all would be the same, right? In general, if you notice, you can make 24 possible words from these 4 alphabets. But when 2 comes, 12 of them would be same and 12 would be unique ones, right? Because every 2 words makes only 1 word over here, right? Is it clear? Or any doubt in this?
I got it, sir.
Okay, so consider a question. Let's say you have this word. We are doing permutation, so let's take permutation only. How many possible arrangements can you make using the alphabets in the word permutation? Anyone? Like, how would you approach it?
Factorial
11
11 upon factorial 2.
11 factorial by
11
2.
factorial by 2 factorial.
11 factorial by 2 factorial. Okay. Because in total we have 11 words, right? 11 alphabets, of which T is repeating 2 times. So I have to take into the consideration this repeated words, right? Okay. So considering the next one, okay, suppose I have this word create. Okay. Now what I am doing in this, I will make all the possible combinations which I can make using the alphabets of this word create. And you need to find, and after making, I will arrange all of them in the ascending order, or you can say that dictionary order, you can say. Okay. Then what will be the 121st word in this ascending order? How would you approach this one?
First,
Okay,
we
how
will
many?
write from
Yeah.
A, C, E.
Okay.
A,
How many
C,
words?
E, T.
We
Ordered
can fix
and
the first word A, and then we can do the permutation of the rest of the word. Then we can fix the next word C on the first place, and then we can permute the rest of the word. Similarly, we can do this and find out the how many number of words there will be, and then this is how we can reach the 121st word.
Okay, great. So see, in dictionary order, if I place all the words which comes in the beginning will start from A only, right?
yes.
So fixing A at the first position, how many words I can make which starts from A?
5 factorial.
By 2.
5 factorial
5
by 2.
factorial by 2
factorial by
factorial
2,
by
yeah.
2 factorial.
By 2, yeah. Don't forget this, that you have 2E repeated in that case. So 60 words we can make which starts from A, right?
Yes.
Then how many words I can make which start from C?
Again, same.
Again 60, right? So we have completed all the words which starts from A and all the words which start from C. Till now we have total of 120 words, right? So the next word would be the 121st word in the ascending order. So what would be the next word?
E, A,
E, A, C,
C, E,
E, R, T.
RT.
Right? This would be the 121st word. Is it clear?
Yes.
Okay. Moving further. Do you all know about the circular permutation?
N minus 1 factorial of
Okay, will it always be n minus 1 factorial?
if it is anti-clockwise, same like n minus 1 factorial by 2.
Okay, yeah, great.
Or n factorial by 2, another case.
Okay, when would it be n factorial by 2? Any example?
And orders are same.
For example, we have questions like arranging the beads or in a circular way, or making a necklace or some kind of questions? Where do we get such kind of questions?
Okay. Let's take this one. I have 5 beads, suppose. Okay, and I have to make a necklace using these 5 beads. So, in how many ways I can form the necklace?
N factorial by 2 ways.
Why n
It's
factorial?
5 factorial by 2.
Okay. No. See,
I hope
generally
I'm
what
not wrong.
happens is, okay. See, in general, there are total of 5 beads, right? In how many ways can I arrange them in circular permutation?
4 factorial.
4 factorial, right?
Yeah.
But in case of necklace, the clockwise and anti-clockwise are same.
N minus 1 by 2, that is 4
So
by
we need
2.
to divide it by 2 because our clockwise and anti-clockwise are
Symmetry,
same
yeah.
in such case. So it would be not n factorial by 2, n minus 1 factorial by
1 factorial by 3, yeah.
Okay.
So why is it n minus 1?
Because in circular permutation, we don't have starting point and ending point. Suppose I have 3, A, B, C. Okay. I need to arrange them in circular permutation. So I can place A here, B here, and C here. I can place A here. I can place A here, B here, and C here. Or I can place A here, B here, and C here. Since in circle, we don't have any starting and ending point, right? So suppose if I start from this point, it would be A, B, and C in this order. If I start from this point, it would be A, B, and C in this order. And in this also, it would be A, B, and C in this order. So these all 3 are same.
Yes, sir, got it.
So to avoid this duplicate cases, we take n minus 1 factorial. But in case of linear, we know that there is a starting point, there is an ending point. So it's only n factorial, right? Clear, everyone? Or any doubt?
Yes, sir.
Okay, let's complicate this beads question a bit. Okay. Suppose you have 8 beads. Okay. And you have to make a necklace of 5 beads. Then in how many ways can you make it?
8 C5 into 4 factorial by 2.
Okay, why so?
Because you can choose any of the 5 beads out of the 8.
Okay.
So that is 8C5. Then once having chosen that, you have n minus 1 over 2, which is 4 factorial upon 2.
Yeah, right. Is it clear with everyone? Firstly, we need to choose which 5 beads I'm going to use to make the necklace. After that, I will arrange these, right? So firstly, I need to select the 5 of these 8 and then arrange them in circular order, right? Any doubt in this one?
No, sir.
Okay, so since we have already included combination for now, you all know when do we use combination?
Selection
Part.
In order doesn't matter.
Yeah, great. Order doesn't matter. Okay. Okay. What all are the difference between permutation and combination? So one important thing to keep in mind is combination means selection.
Permutation is arrangement.
Arrangement, right? Second thing, and the most important thing to keep in mind is in combination, order doesn't matter. While in permutation, order do matter, right? Because whenever I am selecting something, it doesn't matter whether I select A first or B first. At the end, I have selected A and B only. Even if I selected B first or A second, doesn't matter. The selected ones are only A and B, right? While in case of arrangement, whether I am placing A first, B second, or B first, A second, these two are different, right? So that's the basic difference between combination and permutation. Okay. Suppose let's make it a bit. Okay, identify whether we have to use permutation or combination in this. Suppose I have a competition, okay, and in competition 10 teams participated, and I will award the first 3 teams. First 3 teams will be awarded. So in how many ways I can select the 3 teams? Is it a question of permutation or combination?
Combination.
Combination.
Permutation.
10C3.
It's combination.
Combination.
Okay. Now consider the second question. I have 10 teams and first 3 teams will be awarded again. But the condition here is first team will get gold, second team will get silver, and third team will get bronze. Is it a question of permutation or combination?
Permutation.
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 Okay. Why is it so? Because here I need to award the first 3 teams only. It doesn't matter in which order they finish, whether team A finish first, B finish second, C finish third, or C finish first, A finish second, B finish third. It doesn't matter. At the end, I'm awarding only these 3 teams. While in the second question, it do matter who occupies the first place, because first place will get the gold, second will get the silver. So if A finishes first, the A team will get the gold. If C finish first, C team will get the gold, right? So you have to identify the cases where order matters. Then you can simply identify whether to use permutation and combination, right? Okay. Is it clear with everyone?
Yes, sir.
Yes.
Moving further. Okay, let's suppose I have a box. Okay. I have a box of, let's say, there are 5 balls in total. Okay. Out of which 2 are red and 3 are blue. In how many ways I can draw 2 balls from the box?
5C2.
5C2.
5C3.
5C2. Okay. And in how many ways I can draw 2 balls such that I should have at least 1 red ball? At least 1 red ball.
So you can also choose in such a way that you basically choose no red ball and subtract that from 1.
Okay. So how
So
would
that
you do
is
that?
1. So 1 minus 3C2.
1 minus, okay.
That's
3C2.
probability, right?
Oh, sorry,
Would it
sorry,
be
sorry.
negative?
Oh, yeah, sorry. So it'll be 5C2 minus 3C2.
5C2 minus 3TC2.
3C2.
Okay. So why are we doing it?
Because you want to, so the only other, so here 5C2 is total number of ways of choosing 2 out of 5 balls.
Yeah.
3C2 is what you're subtracting is total ways of choosing 2 out of 3 blue balls.
Yeah. Okay. So yeah, in general, I can draw the balls in 5C2 ways. If I subtract those cases in which both the drawn balls are blue, I will get all the cases in which there will be 1 red ball, right? So that would be 3C2
At least 1
for
red
try.
ball. Yeah.
So that 3C2 is the number of ways in which I can draw 2 blue balls from the box, right?
Yes.
Another way to approach it is at least 1 red ball. It means I should have either 1 red ball and 1 blue ball, or I could have 2 red balls. These are the 2 cases, right?
Yes.
For the first case, 1 red ball means out of these 2, I need to select 1. 2C1. And at the same time, I need to select one of these three only, right? So 3C1. Or means either this will happen or this will happen. So whenever there is a or, you add, right? And whenever there is a and, you multiply. So, or two red balls. It means I have drawing two red balls of these two, which I can do in 2C, two ways. So both the approaches will give you the same answer. You can approach either way. Okay.
In the first way, won't that way also include when both red balls are not chosen?
Yeah, it will also include. See, total ways are 5C2, right? So in total ways, the cases are you have 0 red ball, 1 red ball, 2 red ball. All these three cases are considered, right? If I subtract this case, if I exclude this case from 5C2, I will get the case where I will have 1 red and 2 red balls. So 3C2 means 0 red balls. Or in other word, you can say 2 blue balls, right? So we have subtracted this 0 red ball cases from the total number of cases. So what I am left with is all the cases which have 1 red ball and 2 red ball.
Okay.
Is it clear,
Sir,
everyone? Yeah.
No. Here can't we do like this? In the first case, we have chosen one red ball, and remaining there will be 4 balls. 3 blue and 1 red. Can't we do 4C1?
Yeah, that way also you can do. But he's trying to say another third approach is I fix 1 red ball. 2C1. Okay, you are saying 2C1 into 4C1. This one, right?
Yes, yes.
Okay.
I think that would be the
No.
case when it's the case for replacement and non-replacement.
It will have some repetition. Okay, let me show you why you can't do this. Suppose 2 red balls are R1 and R2, okay? And I have 3 blue balls. So in your case, what you are saying is, first I draw 1 red ball, right? Suppose I have drawn 1 red ball. After that, from the remaining, I can draw any, right?
Yes.
So suppose I draw R2. This is one case. Second case would be, suppose I have fixed R2 first. Then it is possible in the next draw I have drawn R1. So by your approach, even though these two cases are same, they are considered different by your approach, right?
Yes.
But in general, it should be same. So that's why if you notice here, it's 8, it is 7. You are getting one extra case.
Yes, but we have 2 different red balls now. That is why I am saying
No,
it is not a same object, it is distinct object.
Yeah, but it doesn't matter which ball I draw first, which ball I draw second. At the end, I am having 2 red balls only, right? So order doesn't matter. But by your approach, these two cases are considered to be different. That's why we are getting one extra case over here, you see. 8 cases we will get here. But actually, there are only 7 cases. Because by your approach, these two are considered different cases. You understood why it was considered different? By your approach? Is it clear?
Yes, now it is clear. I understood. Okay.
Okay. Okay, moving further to it. Okay, you all are aware of properties of combination a bit. Like you know how to open NCR. Right? You can
Asking
solve
for
it.
the formula?
Yeah,
Equal to-
formula.
Is equal to factorial n upon factorial r into factorial n minus r.
Minus r. Okay. For permutation also it is clear, right?
Yes.
N factorial by n minus
N
r.
minus r factorial.
Okay. So if you also notice this formula, this extra division by r factorial is to remove out those order duplicacy. Because here order doesn't matter, right? So to remove those duplicate cases, we divide by r factorial. And but in permutation, order matters, so we are not removing the duplicacy, right? Okay, moving further. Okay, suppose in an exam there are 5 MCQ questions. Okay, and one is getting, like, for every MCQ there are 4 options. So since it's an MCQ, only one would be correct, right? So if you take a random guess on these 5 MCQs, in how many ways can you get none? Okay, what are the chances that you will get all correct? In how many ways you can get all the questions correct?
One way.
One way. Okay, why one way?
Because there's, suppose you have A, B, C, D, that is A for the first one, B for the second one, C for the third one. That is only one way.
Okay, so yeah, to get the first question correct, I have only one way. Similarly, to get second
So
question correct,
4C1, I guess 4C1 into 5.
4C1 into 5. Okay, why so?
Because we can just select one answer, right? That would be the correct answer. So 4C1, and that will be for 5 questions. So into 5, I guess.
No. See, for first question, suppose answer is A. For second option is B. For third, it's C. So in how many ways can you get the first question correct? If you take the option A only, right?
Yes. Got it.
The correct option won't keep on changing. To get the first correct, it's one way. Get second correct, it's one. Similarly, for third, fourth, and fifth question, it's all one, right? So there is one way to get correct. So in how many ways that you won't get all correct?
So that the total number of way of answering the question is what she said is 4C1 into 5. Minus 1 is a way of getting all correct. So that will be 4. The answer is 4C1 into 5 minus 1.
Why is total number of ways to answer is 4C1 into 5?
Because
5, right? Total.
Yeah, but yeah, why 4C1 into 5?
Because see, there are 5 questions.
Yeah.
And each question has 4 options.
Yeah.
So every question you can have 4 choices. So 4C1 and such a repetition for 5 questions. So multiplied by 5. So that's total number of ways of answering the 5 MCQs, and minus 1 way is a way to get all right. But you're thinking of ways where all will not be right? So that's why you subtract the 1.
See, why you are multiplying? See, for the first question, I can select any of the 4.
Yes.
For second question, again, I can select any of the 4. For third question, also, I can select any of the 4.
Yes.
For fourth and fifth, also, I can select any of the 4. So wouldn't it be 4 raised to the power 5? For each question, I have 4 options, right?
Yes. Correct. So it has to be 4C1 raised to 5. Sorry.
Yeah. So it's 4 raised to the power 5 minus 1, right? Just nothing but 1, 0. Is it clear?
Can it be all correct minus 3C1 into 5?
All
3
correct.
all the ways, I mean, choosing from all the incorrect answers.
Okay. Why did you say all correct minus 3C1 into 5? Like, what's the logic behind this?
Yeah, so 3C1 is basically all the options which are not correct. So choosing one of the incorrect answers. I'm not sure, but I'm just guessing that can it be like this?
Okay, so if you consider not, so this will be a case when we have to get 0 answers correct. So for suppose question 1 answer is option A, question 2 it's option B. So for question 1, I can select any of the 3, B, C, and D, right? Similarly, for question 2, I can select any of A, C, or D to get the incorrect answer, right?
Yeah.
So it would be 3 into 3 into 3.
3 to the
Get
power
all,
5.
Yeah, all questions incorrect would be 3 raised to the power 5. But here question is, I should not get all correct. I can get 1 correct, 2 correct, 3 correct, 4 correct, or 0 correct. But I should not get all the 5 questions correct.
Okay.
Okay. So what we did is we have computed total number of ways in which I can answer, which is 4 raised to the power 5. And so 4 raised to the power 5, if you see in general, your total ways include all the cases where you get 0 correct, 1 correct, 2 correct, 3, 4, and 5, right? If I exclude this case where you get all the 5 correct, I will get all those cases where you are not getting all answers correctly, right?
Yeah.
The total is 4 raised to the 5 minus number of ways to get all 5 questions correct is 1.
Okay.
Okay.
Okay, yeah, got it.
Okay, let's modify the question a bit. Suppose instead of MCQ, it's MSQ. So in how many ways will you not get all correct?
What is MSQ?
MSQ means either it could be one option correct, two option correct. It could have multiple options to be correct.
Oh, okay, okay, okay.
In MCQ, there is only one correct, but in MSQ, you can have any correct. A, B could be correct. A, B, C could be correct. Only D could be correct. So you have all those possibilities over here.
Okay, got it, got it.
How would you approach this one? Anyone, any
14
idea?
14 to the power 5 minus 1.
14 to the power
5.
Why 14 to the power 5?
Since MSQ, we can select multiple options.
Yeah.
There are 4 options. So we can select 2 to the power 4 minus 1, 15. We can select 15 from 15 ways to select one answer. To attempt one answer, we can have 15 possible ways.
So in how many ways you can attempt MSQ in general? Either you will take only one option, right? Or you will take 2 options, or you will take 3 options, or you will take all the 4 options, right? In how many ways can you take one option?
4C1 ways.
In how many ways can you take 2 options?
4C2.
In how many ways can you take 3?
4C3.
And 4C4. So in general, the total number of ways to attempt one MSQ question is
15.
4 plus 6 plus 4 plus 1.
So why
15
we are
ways.
adding here instead of
Because
29?
either you can select one option, or you can select 2 options,
Okay, okay, got it.
or you can select 3, or you can 4.
15 to the power 5 minus 1, I think it is will be.
Yeah. So
Yeah,
total number
15
of ways to attempt MSQ is 15, right?
Yes, yes.
So in how many ways can you attempt all 5 MSQ?
15 to the power 5.
15 to the power 5, right?
Huh.
If I subtract all those cases in which I'm getting all the options, all the answers correctly, I will get my cases where I'm not getting all correct, right?
Yes.
So in how many ways I can get all answers correct?
One way.
One way.
One way, right?
Yeah.
So it will be 15 to the 5 minus 1. Is it clear?
Yes.
Okay, so any doubt in permutation combination till now? Anyone?
No.
Or any practice question you have done, you got stuck? Anything?
Yeah. Yes, sir. I have a question on PMF. जिसमें मुझे doubt था.
PMF we will cover, I think, in the next session. We will have week 9 to 12. We will cover PMF there.
Okay, okay, sir. Okay.
Okay. So any doubt in permutation combination for now? Okay.
Sir, there was a question about, I don't remember exactly, but there's a question where there are like dogs on the field, 4 dogs, black and brown dogs.
Okay.
So I don't remember the video exactly, but I have a question about that. So what I can do is I can send you the link or something after this class, or because I don't remember the question. Sorry.
Yeah, just send the link.
Yeah. So
Okay.
yeah, I can remember because I'm so sorry, I don't remember. Otherwise, I would have just put it on the group chat.
No, it's fine. You can. So we still have one more session to discuss. You can make a note of it and we can discuss.
Sure.
Okay. One question, like one small mistake which many people make. Let's see. Suppose you have digits 0, 1, 3, 5, 7, and 9. Okay. And you have to make numbers without repetition. Okay. And you can use only these digits. So how many numbers can be formed which are greater than 20,000? How many numbers you can form which are greater than 20,000? You can use only these digits without repetition. Any idea on this, anyone?
It have to be greater than 20,000, so it will be a 5-digit number. And we can fix the first number as 3, 5, 7, or 9. We can't put it 1 or 0, so we can fix 3, 5, 7, and 9 turn by turn. We can make the 4 cases here, and we can compute the rest of the numbers here like this, and we can add on the total numbers this way.
Okay, so any of these
5
four can
factorial
come at
into
the
4,
first
sir.
place.
It will have 6 digits, right? 0 can be included in
3
anywhere
into
else.
4 factorial.
Okay, why are you saying 3 into 4 factorial? Just give the explanation for your approaches. Okay, so what she said is at the first place we can have any of these 4 digits. Okay, and for the
4 into 5 into 4 into 3 into 2 into 1.
2 into 1. Okay, you are making 6-digit number, right?
Yeah, 6-digit number. First 4, so 1 will be gone there. Remaining 3 will be left out. And any of the 5 places, we can place any of the remaining numbers, including 0.
But if I put 1 at this place, then also I would get a number greater than 20,000.
So actually, we can address this question in two ways, where
Yeah.
two sections where we'll
Cases,
count for 5-digit number first, where we'll fix 2 in the first place, and then we'll add all these combination with the 1 where we'll calculate for 6-digit numbers, which will always be greater than 20.
Yeah. So the common mistake which people make in this is they don't consider the 5-digit number. They only consider 6-digit numbers. So what they do is they consider that, yeah, at first place I can have any of these 5, and remaining I can arrange in 5 into 4 into 3 into 2 into 1. But you also need to take into account the 5-digit number which starts with either 3, 5, 7, or 9, because these all numbers would be greater than 20,000 too, right? So for 5-digit number to be greater than 20,000, I can have any of these 4 at the first place, and remaining I can arrange. So you need to take into consideration these 2 cases, but most of the students take only this case as the answer. Is it clear? So keep in mind this. This is very small information to distract you from the final answers. So just keep in mind what conditions are given and what all possible cases you can make. Okay. Okay. So moving forward.
Sir, I have one question down.
Yeah.
I'll send it in chat on this meeting.
Yeah,
Can
sure.
you explain?
Okay. Get 3 numbers randomly from the set of Real numbers and a set of natural numbers from 1 to n. Okay, yeah, I'm coming to probability, then we will discuss this one. Okay. Okay, so you all, before moving to probability, do you all know what is sample space?
Yes, yes.
What is sample space?
All possible values.
All
Satisfy
possible
a
values of
condition.
Outcomes, possible outcomes.
all possible outcomes of what?
Of
Event.
an
Any of the event.
Any of the event. Okay. So is, okay, what is an event?
A subset of sample space.
Subset of sample space.
Okay. So you are defining sample space using events, and then you are saying event is a subset of sample space.
Oh, from sample space, we need we get the events.
Yeah. Then what is sample space?
Collections of these things. Possible outcomes.
Possible outcomes of what?
An event is a certain condition that would be met.
So all possible outcomes of a random experiment, right?
Yeah, random experiment is.
Do you know what is a random experiment and which experiments are not random? What is random experiment?
Where X takes a certain set of values.
No. Okay. Suppose I'm tossing a coin. Is it a random experiment?
Yes.
Yes.
Why?
Yes.
Because
It will
it be
head or a tail.
head or a tail, and we cannot, and it's random. You cannot say that okay, we have tossed it for the first time, then it will be a head, or it can be anything.
Can't
We
predict,
don't
yeah.
we don't know the exact outcome, right? Now suppose I am driving a car at the speed of 50 km per hour. Okay. And I drove it for 4 hours. So the distance covered by me in the 4 hours, will it be a random experiment or not?
No.
No.
No, because we know that it's gonna be 200 kilometers for sure, right?
Yes.
So random experiment is any experiment in which we cannot say that this will be the outcome, right? We don't know about the outcomes, but we know that it's gonna be something in between this. Suppose if I'm tossing a coin, I don't know the exact outcome, but I know it would be either head or tail, right? If I'm rolling a die, I don't know the exact outcome, but I know it's gonna be any of these numbers, right? Is it clear? So such experiments are called random experiment, and all the possible outcomes, if I list them in a set, it is sample space. Okay. And event is any subset of sample space. Is this terminology clear to you?
Yes, yes.
Yes, sir.
So remember, this sample space is all possible outcomes of a random experiment. Okay, so how do you compute probability? Do you know the basic definition of probability?
Yes.
It is the number of my
Possible favorable outcomes divided by 2.
favorable outcomes divided by total
Total number
outcomes.
of outcomes.
Okay. Okay, now suppose there is a box of balls, okay? And this, suppose I have 10 balls. I have 3 red balls, 5 blue balls, and 2 black balls. So what is the probability that if I draw a ball randomly, it would be a black ball?
C1 divided by 10C1.
Sorry, can you repeat?
1 by 5.
1 by 5. Okay.
Pi C1 divided by 10C1.
So you're choosing only one ball, is it? Out
One
of the
ball,
10?
yeah.
And the
Yeah,
probability that it's a black ball. Okay.
Yeah.
I think it would be 2C1.
Total
1 by
number.
10C1.
1 by 5.
Yeah, 1 by 5 it is. Suppose now I am drawing two balls with repetition or with replacement, you can say. You know what is with replacement? After drawing the ball, noting down the color, I am putting it back in the box. So what is the probability that I will have two black balls?
Two C1 and given by 10 C2.
2C1 raised to 2 divided by 10C1.
Okay, yeah. 2 squared by 10 squared, right? Another way to think of
1
it.
by 25.
Yeah. Another way to think of it is, what are your total outcomes? Total outcome is, at the first draw, you can have any of the 10 balls. In the second draw, again, you can have any of the 10 balls, right? While your favorable outcome is, in the first draw, you can have any of the two black balls. The second outcome, you can have any of the two black balls, right? So it is nothing but 2 squared by 10 squared, right?
Yes.
Okay. And what if I am doing it without replacement? What is the chances, probability of getting two black balls if it's without replacement?
1 by 5 into 1 by 4.
45.
Someone just said 1 by 5 into
1 by 4.
Why is it so? Why did you said 1 by 5 into 1 by 4? Any logic behind it?
It is 2C1 by 10C1 is 1 by 5. And the remaining total will be left out with 9 balls since one ball has been taken outside.
Okay.
So total will be 9C1.
Okay.
So the favorable outcome is 2C1 again. No, 1. One black ball will be left out.
Okay.
I think if I'm not wrong.
It's the numerator is 2C1 multiplied by 1C1 upon 10C1 into 9C.
Yeah.
Okay. And what is the probability if I have to draw one black ball and one red ball without replacement?
One what? Black and red.
One black and one red, yeah.
Without
3
replacement.
Without replacement.
3C1 into 2C1 divided by 10C2.
3C1 into 2C1 by 10C2.
3 by 45.
Anyone, any other approach for this, or you understood this one?
So could you please explain this?
Okay, so what are your total number of outcomes of drawing two balls without replacement?
10C2.
10C2,
But
right? Because
10C1 into 9C1.
okay,
Without replacement, right?
yeah, without replacement. You're saying
So
10C1 into 9C1, right?
9C1. Yeah.
But here, if you see, it doesn't matter which ball I draw first, which ball I draw second. So okay, let's consider an example. Okay, suppose I have three balls on here. Okay, I have one red, one blue, one black. So if I draw red first and blue second, or if I draw blue first and red second, will it be different cases or same? Those two cases be same or different?
Same.
Should be same.
Same, right? But
Yeah.
so here when you are doing this 10C1 into 9C1, you are not removing the duplicate cases. See,
Oh,
10C1
okay.
means in the first draw I can have any of the 10. Suppose I draw red in the first and then I draw on black. Or it is possible to draw black first and then red first. So we are not removing those duplicate cases. To remove those duplicate cases, it should be 10C2, right? I need to divide by 2 factorial.
Correct.
Correct. So it would be 10C2 and not 10C1 into 9C1. Okay.
Okay, okay, okay.
And what are your favorable outcomes? One red and one black.
Okay, okay. 3C1 and 2C1.
3C1 into 2C1, right? These are your favorable outcomes. So favorable upon total, you get the probability. So keep in mind, whenever it is without replacement, you don't have to do like this. Take it together. You have to remove that order case also, right?
Yes, got it, got it, got it.
Okay, let's make it a bit complicated. Okay. Okay, so let's take the question. Let's put in the chat. Priyanka selects 3 numbers randomly from the set of natural numbers 1 to n. Okay, so you have numbers from 1 to n, and you are selecting 3 numbers out of it. So what are your total outcomes? If you are selecting any 3 numbers,
NC3.
NC3. Okay, and we need to find the probability that she will select a triplet. Triplet means 3 consecutive number. It means 1, 2, 3, 2, 3, 4, or 7, 8, 9, like 3 consecutive numbers, right? So in that case, what will be my favorable outcomes?
N minus 2.
N minus 2. Okay, why so?
Yeah. See, the thing is, if you're looking at the first triplet, right, you'll have 1, 2, 3.
Yeah.
Then you'll have 2, 3, 4.
Yeah.
4, 5, 6. And the last one will be n minus 2, n minus 1, n.
Yeah.
So it goes, your value goes from 1, 1, 2, 3 is one set. Last set is n minus 2, n minus 1, 1. So you are having n minus 2 such sets.
Yeah. So in total, I will have n minus 2 triplets in this set, right?
Yes.
Out of that, I need to select any one. So my favorable cases are n minus 2 only, right?
Yes. Yes. Yes.
So what would be my probability? Favorable upon total, which is nothing but n minus 2 upon NC.
NC3.
So please explain how we have calculated the number of triplets here in this set.
Okay, so you see first triplet would be 1, 2, 3, right? Second would be 2, 3, 4. Then 3, 4, 5. And it will go until n minus 2, n minus 1, and n, right? So if you notice the pattern here, your first one begins from 1, second one begins from second, third one begins from third. So your n minus 2th one will begin from n minus 2. So there are total n minus 2, right?
Got it. Thank you.
Any doubt in this one, anyone?
No.
Okay, let's move further a bit. Okay, let's see. So have you all watched all the lectures till week 8, or you have finished till week 12 for stats 1? Have you watched all the videos?
Not also.
Okay. Okay, so let's move to the. Okay, so we know event is a subset of sample space, right?
Yes.
Space. Okay. So suppose I have event A, it could be anything, and I have one event B. Okay. And I need to find the probability that my either of these events occur. Either A occurs or B occurs. So how would I find it?
It'll be you choose 1 out of 2, so that will be half.
Okay. Okay. Let's. You know what is Venn diagram?
Yes.
Suppose this is my Venn diagram. This is my complete sample space. Okay. this is my event A in here, and this is my event B in here. Okay. So either A or B occurs. It means if any of it occurs, it means either A or B occurs, right? If either A occurs, then also it will be my favorable case. If either B occurs, then also it will be a favorable case. If both occurs, then also this condition would be satisfied, right?
Yes, yes.
Right. So I need to take into consideration all the outcomes which are in A and which are in set B also, right? These will be my favorable outcomes. So which will be nothing but A union B.
Yes.
All the outcomes in A and B, right? So whenever we have to find the probability of either of these event occur, we find the probability of A union B, right? Is this clear?
Yes.
Yes, Payash.
Okay. And when you have to find the probability that both A and B occurs,
A intersection B.
A intersection B, right? Because it will have all those common outcomes of A and B, right? This region. So whenever we have to find the probability that both A and B are occurring, it would be A intersection B. Okay, suppose I have to find the probability that A does not occur. Suppose this is my event A, this is B. Then how would I write A doesn't occur?
B minus C.
It would be
A complement.
A complement,
B.
right? Okay, why B minus A?
It could be B minus A intersection B.
B minus A, because only the elements in B but not in A, and not even the intersection part of it.
No, but condition is only A doesn't occur. We are not saying anything about B should occur or not. So it could be anything in a sample space, all those elements of sample space which are not in A, right? A
Not.
should not occur. We are not caring about whether B occurs or not.
Okay, including
But
the
this,
universal set.
Then would be 1 minus A.
yeah, so it would be A complement.
A
So in general,
complement.
it would be A complement. Or you can write it as 1 minus probability of A. Okay, if I say A doesn't occur, but B occurs. In that case, what would be it?
It'll be A complement intersection B.
Yeah, this region, right? B
Yes,
should
yeah.
occur, but A should not occur, right? So you can write it as A complement intersection B. Is it clear with everyone? You are now able to visualize the events.
Yes, sir.
Okay, moving further, let's move to a question. Okay. Okay, suppose I need to select a number from 1 to 20, any number from 1 to 20, okay? My event A is that odd number is selected. Event B is the number selected is divisible by 3. And event C is selected number is divisible by 5. So what is the probability that all my 3 events occur? Probability of all 3 events occurring.
How many numbers are we choosing?
Only one we are choosing.
Okay, okay, okay.
Just try it. I will be back in a minute. Okay.
Probability of A intersection B intersection C.
Is it 1 by 20?
It would be, I think, 1 by 20.
Yeah. Yeah, it's 1 by 20 because there's only one value 15 which satisfies all the conditions out of 20 numbers.
Yeah,
It's 1 by
but
20.
the only like 15th digit is the one that could satisfy
Yeah,
all
correct,
the three.
correct. Yes.
Probability of A intersection B intersection C.
Okay. So how did you guys approach this question?
So firstly choosing all the odd numbers and
Odd numbers.
Firstly, what is your sample space? It's all number from 1 to 20, right?
Yeah.
Yeah.
What all numbers are in A?
1, 3, 5, 7, and so on till 19.
Yeah, right. Okay. What are numbers in B?
3, 9, and 15.
3,
6,
6,
9, 1,
3, 6, 9, and 15. No.
18 also, right?
18.
18.
What are numbers in C?
5, 10, 15,
5,
20.
10, and 15.
20 also, right?
Yeah.
Yeah, including 20.
Okay. So all three events should occur. It means A intersection B intersection C. It is my favorable event, right? How many elements will be in A intersection B intersection C?
1.
1.
One only. 15 only, right?
Yes.
Yeah.
So if you compute probability, it would be number of favorable outcome is 1, while total outcomes are 20.
20.
Is it clear?
Yes, sir.
Okay, so let's move further. Do you know which events are called independent events? And which events are called disjoint events?
Yeah, see, actually, I always have a confusion between mutually exclusive and independent. Like sometimes I don't understand the difference.
Yeah, mutually exclusive is same as
A
disjoint.
intersection B is equal to null.
Yeah. So disjoint events are those in which there is nothing common between the two events. So if A intersection B is a null set, we can say that it's a disjoint event, right? When are events said to be independent?
When
When
the
evidence of one is not disturbed by the other.
Okay, great. And how would you write it mathematically?
Section B is equal to A into
Probability of A into probability of B, right? If you can, if your intersection is equal to this thing, you will say it is. Okay. What about in case of three events? How would you
Probability of
identify?
A multiplied by B multiplied by C.
Any other condition? Or only this?
we could also have a probability of A into probability of B plus probability of B into C and A into C.
Can you repeat? Probability of?
Probability of A intersection B equals to probability of A into probability of B. I mean, the combination of the other events should also be those independent.
Yeah. So for three events, you need to check all these four conditions. Only then you can say it is. The three events would be independent if all the four conditions would be satisfied. Only by the first condition we cannot say that three events are independent. Okay. For three events to be independent, you should have all these four conditions satisfied. But when we say that pairwise independence, three events to be pairwise independent. So pairwise independence means each pair should be independent. So what all possible pairs are there? A intersection B, A intersection C, and B intersection C. If these three conditions are satisfied, then they are pairwise independent, right? And when this fourth condition will also be satisfied, you say that all these three events are completely or mutually independent. Okay.
Ishan, could you represent two independent events in the form of a Venn diagram?
In form of Venn diagram, it would be a bit difficult. Okay, let's cover the concept of conditional probability, then we would be able to visualize a bit.
Great.
We'll do it. Okay. Okay, so here can you tell me if event A, B, and C are independent or not? Or
dependent? They are dependent.
A, B, C are dependent. Okay. And what about A and B?
Dependent.
Dependent. Why?
Because there are certain elements in A which also occur in B.
Okay, so
Actually, all three are independent, no?
why?
They're three separate events, even if they have common elements.
Yeah, if they have common element, it means they are not disjoint. But for independence, you need to check these conditions, right?
Okay.
Okay. So just tell me if all these three event A, B, C, and are independent or not.
They are not. They are dependent.
Dependent. What about A and B?
Because occurrence of one.
They are also dependent because when we check the condition, probability of A intersection B equal to probability of A into probability of B, we are not getting LHS equal to RHS. So they are dependent.
So let's. So A is your divisible. A is your odd numbers, right? 1, 3, 5, 7, 9. B is your all those numbers which are divisible by 3, right? So what is probability of A?
10 by 20.
10 by 20. Probability of B?
6 by 20.
6 by 20. What is A intersection B? What all elements will be in there?
3, 9, and 15. So 3 by 20.
B is equals to 3 by 20, right? And what is probability of A into probability of B?
60 by 20.
60 by?
They are independent.
Yeah, it's got
Independent,
3
right?
by 20 only.
You got it. You have to check the independence always by the condition. You cannot just by looking at the events tell whether they are independent or not.
Okay.
What about event A and C?
Independent.
Independent. Okay, but its probability of C is 4 by 20, right? Probability of A is 10 by 20. So, and what is probability of A intersection C? Two by 20, right?
2 by 20.
2 by 20. So are these two equal?
Yes.
Yes, so A and C are also independent. But okay, so here notice that A and B are independent, A and C are independent, but A, B, C are not independent events, right? Because this condition is satisfied. Okay, not this one. This condition is satisfied. I think, yeah, this one is also satisfied, but this condition is not satisfied. So A, B, C are not independent event, but A and B are independent, and A and C are also independent, right? Is it clear?
Yes, yes, yes. So it is possible for independent events to have common elements, just like in
Yeah, it
this.
is possible.
Okay.
Yeah, it is possible. If they don't have any common element, they would be disjoint.
Okay, okay, got it, got
And
it.
in general, independent events will have something in common for sure.
Oh, okay, okay.
Okay. Because if they don't have anything in common, then A intersection B will always be 0.
Okay. Is it possible for an event to be both independent and disjoint?
No, no. It would be either disjoint or independent.
Oh.
Like choosing the probability of intersection of odd events and even numbers is a disjoint one.
Yeah,
Yeah.
disjoint. But they won't be
Yeah.
independent. Okay.
Because then A intersection B will be 0 in both the cases, right?
Yeah.
Okay, got it, got it.
Okay. Moving further, do you know the formula how would you compute A union B? Suppose you know that probability of A is
P of A plus P of B minus P of A intersection B.
Yeah.
Okay, you know this formula, right? And how did we get this formula? Are you aware
Because
of
when
it?
computing A and B, we are choosing A intersection B section twice, so we'll remove.
Yeah.
Okay. Great. Okay, let's move to the conditional probability. So you do know what is conditional probability?
Yeah, occurrence of one event based on the other event has already occurred.
Okay. Okay. So till now we are computing probability in terms using our sample space, right? For A, for B, we used our sample space, we computed total number of outcome, favorable outcome, we got the probability, right? Now suppose there are two events A and B. Okay. And we know that event B has already occurred. So now visualizing it from Venn diagram, let's see. So initially this was my complete sample space, right? This was event A and this was event B. Now I know that my event B has occurred. Whenever we say that event B has occurred, it means your new sample space is event B now. This is your new sample space, this red circle. Okay. Then what is the probability of happening of event A given event B has occurred? So see, now your total outcome is complete sample space, which is event B, right? This is your new sample space. And your favorable outcome is
P of A intersection B.
this thing, this portion of A which is inside B. That is why probability of A given B is nothing but probability of A intersection B upon probability of B. Okay. Do you get the concept of conditional probability? Like what happens when we say that an event has occurred, already occurred? It changes your sample space to that event. Okay. Is this thing clear?
Yes, sir.
Okay. So yeah, you want to visualize independent event through Venn diagram. Okay. Now see. Initially, this was your sample space, right? This was your event A.
Yes.
This was your event B.
Correct.
Probability of A is this much portion of sample space.
Yes.
Let's say it's 0.40. Let's say, okay, 40% of complete sample space.
Okay.
Right? Now, do you know independent means that occurrence of one event should not affect the happening of other, right?
Hmm.
So when event B has occurred, it means my new sample space is this one, right?
Which
Within
one?
the new,
Ah,
this red circle is my new sample space now if B has occurred.
correct.
Within the new sample space, if you see, this is the chances of happening of A.
Yeah.
It is also 40%. Then I would say that happening of B does not affect the chances of happening of A because it is still 40%, my new sample space. So in general, occurrence of A does not affect my probability of happening of event A. So A and B are independent. You can now open it. You know the formula for A given B? It is probability of A intersection B upon probability of B. It should be equal to probability of A. So you can see we get the formula for independence here. Right?
Okay.
The general condition is this: happening of B should not affect the probability of happening of A. In original sample space, it was 40%. Even when I change my sample space to event B, it is still 40% of the new sample space. So chances of A are remaining same, whether B has occurred or not occurred, right? Is this thing clear? Or any doubt in this, anyone? Please ask if you have any doubt till this step before we move further.
I have a small doubt.
Yeah.
40% is you say, but the new sample space has changed, no?
Yeah, new sample space is this. My B is my new sample space, right?
And 40% of B means that
This area.
that reduces the original value, right? Original number of elements.
Yeah. See, this area is 40% of complete sample space, right?
Yes.
This area is 40% of new sample space.
Okay. So the percentage remains the same, but elements are left out.
Element reduces. Yeah, it doesn't matter because, but my chances are same still, right? Still, it's 40%.
Okay.
Even though B has occurred.
Okay. I understand.
That's why they are independent. Okay, let's try some questions on conditional probability.
Sir, is it necessary that the percentage remains same?
Yeah, if A and B are independent, this would remain same. This is the condition for independence, right?
Okay.
It is derived from this thing only. This is the main logic behind it.
Got it.
Okay. Try some questions on conditional probability. Do you guys have sample questions also, right? Are you doing those questions? You have the sample set of questions to attempt.
So we just have only mock test to practice on that. Just one paper.
Okay. Okay, let's try some questions. Okay. Firstly, let's try this one. Okay. Suppose there are three persons. Okay. Person A, person B, and person C. And we have assigned a task to each of them. The same task we have assigned. Okay. The probability that A will complete the task is 1/4. Probability that B will complete the task is 2/6. Probability that C will complete the task is 1/5. And all these three are performing the task independently. So what is the probability that my task will be completed?
One by 4 into 2/6 into 1/5, right?
Why so?
We have to take the intersection of all cases.
Intersection. Okay, what does intersection mean over here? What does this A intersection B intersection C means?
A and B and C.
The task can be performed by any of the three.
Yeah, any of the three.
So, or all the three. So
Task is performed by all the threes.
all the three.
All the three are performing the task. The respective probabilities of them completing is 1 by 4, 2 by 6, and 1 by 5. What is the probability that I will get the task completed?
Uh, 3 by 4 plus 4 by 6 plus 4 by 5. Meaning that none of them.
It's exceeding 1 already.
It can be probability of A plus probability of B plus probability of C minus probability of A intersection B intersection C. It can be like this.
Okay, first let's try to make the cases. Suppose I have given task to all the three, right? If A completes the task and B and C don't complete it, my task will be completed, right? I'm getting my work done by A, right? If B done, A and C not able to do, still my task is completed. If C does it, then also my task will be completed, right? If both A and B complete the task and C didn't, then also my task will be completed.
Yes.
If A and C does and B doesn't, then also my task will be completed, right? If B and C does it and A doesn't, then also my task will be completed. If all the three able to complete it, then also my task will be completed, right? So there are 7 cases in which I can get my task completed, right? Is this thing clear?
Yes.
Now
Yeah,
when this
2 by 5.
okay.
1 minus no one completes the task.
Yeah.
Kind of.
The better way, instead of computing probability for 7 cases, we can do is 1 minus probability no not task not completed, right? It means none of them did it, right? So what will be the how would you compute probability that task is not completed?
4 into
1
4 by
minus 1 by
6.
4 into 1 minus 2 by 6 into 1 minus 1 by 5.
Yeah. A didn't complete the task.
A complement, B
And
complement, C
A
complement.
complement intersection B complement intersection C complement.
Right? None of them completed the task, right? Since these three are independent events, it means their complement will also be independent. Okay, one thing to keep in mind, if A and B are independent, then A complement and B will also be independent. B complement A would also be independent. A complement and B complement would also be independent. Okay. So here, if A, B, C are independent, then their complement would also be independent, right? And we can compute the probability. Is this question clear? Or any doubt
Sir,
in this? Yeah.
why can't we simply take the probability of A union B union C because we just need
Yeah, it's the same thing.
right.
Yeah, you can do it. A union, B union, C will also give you the same answer. But do you know the formula for union of 3 events?
It will be probability adding of all the events, like probability of A plus probability of B
Yeah.
plus probability of C minus probability of A intersection B
Yeah.
minus probability of B intersection C and minus probability of A intersection C. Oh, sorry, B intersection C all and minus probability of all the events intersection. Right?
Plus probability of.
Plus, right?
It will be plus. So sorry.
So this formula was not covered in lecture. So yeah, if you know, you can use this one. But another way to use it, approach it is like that also, right?
Okay.
So you can also use this. Because A union B union C means either of them completed, right?
Yes.
Is this question clear to everyone or any doubt in this till now? Anyone? No doubts?
No doubt.
Okay, let's further then. Next, let's cover the concept of law of total probability. Do you know what is law of total probability?
The sum of all the probabilities is equal to 1.
Okay, no, that's it. Okay. Suppose you have a sample space, okay? Complete sample space you have, and you divide it into 3 parts. Not necessarily equal, it can be unequal as well, okay? Suppose this is first part is E1, second part is E2, second part is third part is E3, okay? The only information I have is I know about individually about these parts, E1, E2, and E3. Okay, I know the probability of E1, I know probability of E2, I know probability of E3. Suppose I need to find the probability of this event E, this big event E. How will I find it? If I know only about these 3 parts, E1, E2, and E3. Individually, I know about E1, E2, and E3. How can I compute this probability of this event E?
Probability of E1 given E plus probability of E2 given E plus probability of E3 given E should be equal to E.
Why E1 given E? Okay, what would be this region? What would be this region?
On intersection E.
Even intersection E, right?
Correct.
E1 intersection E plus E2 intersection E, right? Plus E3 intersection E, right? If I add these 3 parts, I can get this probability of this event E, right?
Yes.
Okay. So now if you remember the formula for conditional probability, okay, recall. Formula for conditional probability was probability of A intersection B upon probability of B, right? From here, can I write probability of A intersection B equals probability of A given B into probability of B? Can we do it? Right. So using the same formula over here, I can write it like this, because individually I have information about each of the parts, so I know these probabilities, right? So adding all these 3, I can get the probability of this event E, right? Is this thing clear?
Yes.
So this
So
is
could
my
you
law of,
repeat this? How probability of ease would be this?
see, individually I know all the information about E1, E2, and E3, okay? And I need to find the probability of this big event E. So what I can do is, this blue shaded region, it would be E intersection E1. This region would be E intersection E2.
Okay, got it.
So I'm adding these 3, okay?
Okay, got it.
So this is called law of total probability. Okay? Is this thing clear, everyone?
E1, E2, E3 must be disjoint, right?
Yeah, E1, E2, and E3, they all 3 must be disjoint. These are 3 parts of my sample space. Okay? You can have 4 parts, 5 parts. Accordingly, you will have the formula extended to E4 intersection E plus E5 intersection E, right? There could be n parts you can make of the sample space. And all those parts should be disjoint. Okay. Okay, moving further, suppose the same condition you have over here. Again, you have three parts: E1, E2, E3. This is your complete sample space. And you have this event E. Okay. Now you know that event E has occurred. This information is given to you that event E has occurred. Okay. Then you have to find the probability that it occurs in this E2 region. It occurs in this region. How would you find it?
So did you mean you have to find E intersection E2?
It would be reversed, right? Probability of E2 given E.
Yeah. It is given that E has occurred. Okay. Given that E has occurred, what is the probability that it's occurred in the second part, E2? So it would be probability of E2 given E has occurred. So again, you can apply the formula for conditional probability.
Ishan, but why would you shade the whole region? Only the intersection part has to be shaded, right? Because the sample space becomes E.
Yeah, sample space become E. So you will consider only.
So only the region inside
would be your region. That will be your favorable region, right?
Correct, yeah.
So given that E has occurred, I need to find the probability that it has occurred in the second part. It would be probability of E2 given E, right? So by using the formula of conditional probability, I can write it like this, right? Probability of E we have computed using the law of total probability. Right? E intersection E2. This information is already known to us because we have information about each of the part. So if you notice here, we are kind of going the reverse thing. We know that this event has occurred. We need to find in which portion of sample space it has occurred. So it is nothing but the Bayes theorem whenever we go in reverse. Is this thing clear? We will go to examples to make it a bit more understandable. But you are getting the concept of law of total probability and Bayes theorem till now. What's the intuition behind it? Okay. Shall we move to the example or any doubt in the concepts?
No doubts. It's clear.
Let's move to the. Okay. Suppose you have a box. Okay. In this, information given to you is that 45% of balls are blue. Okay. Remaining 55% of balls are red. Okay. Among all the balls, you know that within this box, 40% of balls are metallic. And remaining 60% of balls are plastic balls. Okay. You need to find the probability that the drawn ball Okay, we have drawn one ball from it. Okay. You have to find the probability that the drawn ball is blue and metallic. Okay. If you know that of all the metallic balls, %60 are red. Is the question clear? You have a box in which 45% balls are blue, 55% are red, 40% of which are metallic, 60% are of plastic. If you know of all the metallic balls, 60% are red, what is the probability that the drawn ball is blue and metallic? Is the question statement clear? Okay, so how would you approach this one?
So assume that there are 100 metallic balls.
Okay.
Okay. And out of that, you're saying the 60 are red and 40 are 40 are blue, correct?
No, 40 are metallic, 60 are plastic. 45% are blue, 55 are red.
Out of the total.
Yeah.
But you're saying of all the metallic balls, 60% are red, right? Which you've written
Yeah,
on the
of the
slide.
metallic, 60 are red. Yeah.
Okay, out of the metallic balls, 60 are red. That means 40 are blue.
40% would be blue. Yeah. 40%
Correct.
metallic balls would be blue. Yeah. Correct.
Okay, so the thing is, if you're considering, so out of, if I'm considering 100 balls,
Yeah.
metallic are, out of them 40 are blue, correct? Then if I take 40 balls, 16 will be blue.
Okay, you are saying, let's suppose there are 100 metallic balls, right?
Yeah, yeah,
60 red,
yeah,
40 blue. Okay.
yeah. But we are actually having 40%, correct? So
Yeah.
the thing is, imagine that 100 is our original sample space. Out of that, 40 you're taking. So 40% of 40. So you'll get probability as 0.16.
Okay, 1 minute. So you are saying, let's suppose there are 100 balls in total, right?
Yes, 100 in total. Initially, when you
Okay.
start,
Yeah.
okay, you're having 100 balls in total. So you're getting 45 blue and 55 red.
45 blue and 55 red. Yes.
Okay, now let's go to the metallic and non-metallic part. 40 are metallic, 60 are plastic.
Okay.
Okay, 40 metallic, 60 plastic.
Okay.
Out of the 40 metallic,
Yeah.
right? 40% is blue. So 40% of 40 metallic.
It is 45 totally blue, no? So 40 out of 45 blue.
What's the final answer according to you?
Answer 0.16 is what I think.
Okay, 40% of these metallic balls are blue, right?
Yeah.
So 16 balls would be blue and metallic.
Correct.
So favorable cases would be 16 and total would be 100. Okay,
100.
that's by the assumption of 100. So how would you do it by the probability, like creating events, and then how would you approach it?
Okay. Okay.
We can use the formula. No?
We are looking for the event where it satisfies both the condition blue and metallic. So
Yeah, see, this answer is correct, but how would you do it in probability way? It's just by assumption way, right? 100 balls, this much would be this would be this. But how would you actually use the events and probability to solve this one? Okay. See, in general, like let's say probability of drawing a blue ball, it is 0.45, right? Because 45% of balls are blue, right? So probability of drawing a blue ball is 0.45, right?
Yes.
Probability of drawing a red ball is 0.55, right?
0.55.
Probability of metallic ball would be 0.40.
Yes.
Probability of plastic ball would be 0.6, right? Now, of all the metallic balls, 60% are red. What does this mean? How would you write in terms of events? It means
60% of all the metallic balls.
yeah, it means given metallic ball.
Even
P of
metallic.
R by M B
Yeah.
complement by M is equal to 6.
Given metallic balls, probability of being it red is 60%, right?
60.
So probability of blue given metallic would be 40%, which is 0.40, right?
0.40.
We need to find the probability of blue and metallic.
Yes.
It means B intersection M, right?
Yes.
That's what blue and metallic means.
Yes.
So we can write it as B given M into probability of M,
Yes.
which is nothing but 0.40 into 0.40, 0.16, right?
Okay.
So you are able to write it in terms of events and solve it also, right? Is this approach clear or any doubt in this one?
It's clear.
Let's move to another one. Suppose you have made a machine learning model, okay? So machine learning model predicts the image of dog, okay? So it predicts correctly in 95% of the cases, okay? First information given to you. Second information given to you is if the image is not of dog, model will still predict dog. In 30% of cases, okay? Suppose you have 100 images in total. Of these 100 images, 40 are of dogs and 60 are of any other animal, okay? Now, if model predicts dog, what is the probability that it is actually a dog? Is the question statement clear?
So the first statement what is written here, predict correctly in 95% of cases. Does this mean the picture is dog and it's predicting it's a dog?
Yeah.
Okay.
So if I have a machine learning model, okay, if I show him an image of dog, he will predict, the model will predict it correctly 95% of the times. Okay. If I show an image of any other animal, it will still predict it to be a dog in 30% of the cases. Okay. Now suppose I have 100 images of which 40 are dog and 60 are of other animals. I have chosen one of the image randomly and shows it to the model. Now the model predicts it to be a dog. What is, you have to find the probability that the image which you have shown to the model was a dog actually. Any doubt in the question statement? Anyone?
No, sir.
0.67.
0.67, yes. Okay. How did you approach this one?
So here it is actually given that the model predicts the dog and we need to find that it is actually a dog. So I just use the formula.
Okay, you are able to identify that it is Bayes theorem.
Yes, sir.
Okay, so yeah, before moving to solution part, let me show you the visualization we did for Bayes theorem. This is your complete sample space, right? This is
Yes,
your
sir.
all your 100 images, right? Of which your first part, even images of dog. You know there are 40 dog images, right? And second part is 60 other animals, right? This is your event E. Event E is that model predicts a dog, right? So you're able to visualize it like the concept we discussed earlier, law of total probability and Bayes theorem. Or any problem in this, anyone? Now we know that this event E has occurred, right? This event E has occurred. We need to find the probability that it has occurred in the even part, right? Are you guys able to visualize it and understand why is it a Bayes theorem question?
Yeah.
Means we are taking the probability of event even when E has given, like E have
Yeah.
happened.
Okay, so what we need to find is we need to find the probability of even given E, which means probability that image is of dog given model predicts it to be a dog, right?
Yes.
So what is the formula for it? E intersection even
Why
the
is the
probability of
E?
Okay, so how would we compute probability of E? We use law of total probability, right?
Yeah.
Okay, so what would be the probability of E? It would be E intersection E1 plus E intersection E2, right? This E intersection E1 and E intersection E2, right?
Yes, sir.
Okay. So we can write it as probability of E given E1 into probability of E1 plus probability of E given E2 into probability of E2. So see, E is model predicts dog. E1 is images of dog. E2 is image of any other animal, right? So what is probability of E1? From the question, can you identify what is probability of E1?
0.4.
0.4, because of these 100 images, 40 are of dogs, right? So probability of image of dog is 40 by 100 or 0.4. Probability of E2 is 60 by 100, right? Are you guys getting this thing or any doubt till now? Anyone, any doubt? No. Okay. Now what is the probability of E given even? What is E given even firstly? How would you read it in terms of English statement? E given even?
The model predicts it's a dog given that the image is of a dog.
So what is the probability of it?
70%. No.
0.95.
95. 95% of the times model predicts correctly, right? So it is 0.95, right? What is the probability of E given E2? Firstly, what is E given
0.3.
E2? Yeah. Given that image is not of dog, model still predicts it to be a dog. It is 0.3, right? So you know this value, you know this value. You get the value of probability of E, right? We have the denominator part. For numerator, we have just computed this value, right? This is my numerator, right? I know this value, I know this value, I can compute my numerator as well. And plugging in, we will get the final answer. Is this clear to everyone? Or any doubt in this? Are all the concepts of probability clear? Anyone, any doubt, please ask. No doubt. Huh? Okay. Do you guys want more question or more questions on Bayes theorem you want to practice?
Yes, sir. Because Bayes theorem is little. We require a few more questions on Bayes theorem.
Okay. Consider one more question. Let's say. Okay. So there are students from 3 colleges. Okay. X, Y, and Z. Okay. And we know that 30% of, okay, we have organized a tournament or something, considered any competition we have considered. So given information is that 30% of participants are from college X. Okay. 20% of participants are from college Y. And 50% of participants are from college Z. Okay. Next information given to you is, of all the participants of college X, %50 are girls. Of all the participants of college Y, 40% are girls. And of all the participants of college Z, 60% are girls. So if I'm choosing any participant randomly, what is the probability that selected participant is a girl? Are you clear with the question statement? Is question statement clear to everyone?
Yes.
Okay, so how would you approach this one now?
So what we have to find?
That the selected participant is a girl. If we are selecting one participant at random, what is the probability that selected participant is a girl?
0.53.
0.53. Okay, how did you approach it?
Okay, so we need to find the number of participants which are girl. So it is, first we will find the probability of X, which is 3/10, and then we'll multiply with the number of girls, which is 1/2. Then same goes for Y, which is
okay
2/10 into 4/10.
Yeah.
Yes, and then same for Z.
Okay, yeah. Is it clear with everyone?
We'll add or
Yes.
we'll multiply.
Okay, see, if you visualize this question, it would be something like this. These are all your participant, okay? These are all your participant, complete sample space, right? This part is from college X. This part is from college Y. And this part is from college Z, right? And this is girls. Girls from college X, girls from college Y, girls from college Z. You need to find the probability that the selected participant is a girl. So how would you find it? First, I will take this area, right? Probability of girls and college X, right? Plus this area we will take. Remember law of total probability. Then this area we will take. Is it clear, everyone?
Yes.
Then we can write it in terms of this, right? Okay, what is the probability of X here?
30%.
30% or 0.3, right?
Easy.
Probability of Y, 0.20. Probability of Z, 0.50, right? What is the probability of G given X? What does it mean? What does G given X means? In
Girl is
terms of
from
English.
X.
Yeah, girl. Yeah, given that the participant selected is from college X, the probability of it being girl, it is 50%, right? Because of all the participant of X, there are 50% girls. So given that the participant of is from college X, the probability of it being a girl would be 50%, right? Similarly, G given Y would be 40%, and G given Z would be 60%, right? Is this clear?
Yes.
So on computing, we will get 0.53. Now let's modify the question a bit. Suppose the question says that if selected participant is a girl, then what is the probability that she is from college X? How would you compute it?
Probability of X intersection G by probability of that it's a goal.
0.5. So 0.28.
Right? Yeah, we know probability of girl. X intersection G you have already computed, right? And if you visualize this question, it is the Bayes theorem. We know that this event G has occurred. We know this event has occurred. You need to find the probability that is occurred in this portion of sample space, right? Given this event has occurred, you have to find the probability it has occurred in this first portion of sample space. So X given G, or you could write it as X intersection G upon probability of G. Probability of G we have already computed. X intersection G you already know right? Is this question clear or any doubt in this one? Anyone, any doubt?
Oh, no.
No, sir.
Okay, so you all are clear with permutation combination?
Yeah.
And probability,
Yes.
independent events, disjoint event, you are able to differentiate.
Mm.
And conditional probability and Bayes theorem, is it clear?
Yes.
Okay. Any doubt or shall we close for today? Anyone, any doubt?
I have a question related to the probability mass function. So you can either take it now or in the next class, whatever you feel.
Okay, what's the question? Just tell me. Yeah.
Okay. It says that K takes the value, the probability of P of X is equal to K into 3CX upon 3C 3 minus X.
K into
3. So P of X is equal to K into K multiplied by numerator is 3CX, denominator is 3C3 minus X.
Okay.
And X takes the values 0, 1 and 2.
Okay.
What is the value of K?
X takes the value 0, 1 and 2, right? Okay. So you know that if I add all these probability of possible values,
Yes.
it should equal to 1, right?
Correct, yeah.
So if X equal to 0, it would be K into 3C0 upon 3C3.
Yes.
So X equals 1, it would be K times 3C1
Yes.
upon 3C2 plus
Yes.
K into 3C2 upon 3C1, right?
Yes.
So first term would be only K, right?
Yes.
3C0 is 1, 3C3 is 1,
Yeah.
plus.
Yes.
Next
Yes.
term would be again 1.
Yes.
Next again would be only K, right?
Yes.
So K is 1 over 3.
So actually the answer is coming in the question paper as 0.5. That's why I was confused.
Okay, no, it's 0.3.
Okay, so
1.33.
it's possible that the answer can have printing mistakes also.
In the mock, is it right?
Yeah.
Okay, we will look into it. Yeah, but answer is 0.33.
Okay. So I'll just put the link in the chat box. You can see.
Yeah, sure.
Okay, because it's the second question. So I put the link.
Okay. Second question, right?
Yes, sir. Yes.
Okay, it would be 0.33.
Okay, sir. Okay. So actually, I was thinking of I
Can
was
you
just
repeat?
thinking how it's 0.9.
No, yeah. It is
Okay.
printing error. Okay.
Okay, sir. Thank you so much.
Okay. Anyone, anything else?
Sir, I have a question.
Yeah.
Question in the chat.
Okay. In a subject, duration of 5 weeks, the probability to get pass mark and receive the marks obtained in the previous week. Okay. Okay. How did you approach this one?
Sir, actually, I'm unable to understand this question completely. So,
The probability the student failed in the 4th week. Okay. Okay. See, what the question is trying to say is, read it side by side. Yeah. In a subject, there are total of 5 graded tests you will be having, right? Okay. The probability that student get a pass marks is dependent on previous week's test. Okay. Okay. So if you have passed this test, then probability of passing the next one would be 80%, right?
Yes.
And if you have failed the previous one, then probability of passing would be 40%, right?
Yes.
Okay.
Yes.
Assume that every student gets passed in the first week graded test. Okay, it is given that you have passed in the first one. Okay, so you are left with only 4. If the student gets pass marks in exactly 4 weeks, but if the probability that student failed in the 4th week. Okay. So in how many ways can you pass exactly in the 4 weeks? It is given that we have passed in the first week, right? So it is possible that I pass in next 3 and then fail, right? Or I pass in the next 2, then fail, and then pass, right? Or I pass, then fail, and remaining 2 I pass, right? Or second one I fail, and then I pass in the remaining 3. These are the only cases when I can pass exactly 4 out of 5, right?
Yes. Yes.
Yes. So what would be the probability of first one? So what is the chances of getting passing the second test? It's 0.80.
0.8.
Then passing the third one, again 0.8. Passing the fourth one, again 0.8. And then failing the last one would be
0.2.
0.20, right? Similarly, for this one, passing the second test would be
0.8 into 0.8 into 0.2 into
0.2 into
0.2.
0.4, right? Because if I fail, then probability of passing is 0.40, right? Similarly, for third one, passing the second test is 0.80. Then failing is 0.20. And after fail, I have to pass, it would be 0.40, right? And then after passing, again passing, it would be 0.80, right?
Yes.
For the last one, after pass, I need to fail, it would be 0.20. Then after failing, probability of passing is 0.40. And then it would be 0.80 for the remaining, right?
Yes.
So consider that you are given event A is you pass exactly 4 of 5 weeks, okay? And your event F is that you fail in the 4th test, right?
Okay.
So we need to find probability of F given E, which is nothing but probability of F intersection E upon probability of E, right?
Yes.
Probability of E would be nothing but the sum of these 4, because these are the 4 cases of passing exactly 4 out of 5, right? And in
Got it.
F intersection
It's
E,
divided by sum of all the cases.
yeah, it is only this case, right?
Huh.
So we know F intersection E, we know probability of E, you can compute it, right?
Thank you, sir.
Clear, right?
Yeah, clear. Thank you.
Any other doubt, anyone?
Ishan, that question about the probability of the dogs on the field, right? I will, I'll bring it in the next class.
Yeah, sure.
Okay, because I'm sorry, I was not prepared to bring that question up. I will be more prepared next time.
Yeah, sure, it's fine.
Okay, thank you so much, Ishan. Thank you, everybody. Bye.
Yeah, thanks everyone.
Bye.
Bye. Good night. Yeah.
Bye.